Welcome everyone to the webinar where we will talk about how you can tackle your dark data challenge with AWS Glue. My name is Prajakta Damle and I'm the Senior Product Manager for AWS Glue. And I also have Ben Snively with me, and I'll let Ben introduce himself.
Yes, hello. Thank you for joining. My name is Ben Snively. I'm a Specialist Solutions Architect in Data and Analytics.
Thanks, Ben. So today we'll look at what exactly is dark data and see how Glue can help you discover your data, understand various data properties, and provide tools to process and transform this data so it's ready for analytics. I have a few slides to go over, and then I'll hand it over to Ben to show you an end-to-end demo that puts a lot of these concepts into action. So let's get started. What exactly is dark data? Oftentimes, we've seen that as the data volumes have grown, the availability of prepared data for analytics hasn't really grown as much. This often leads to data that just sits in various different repositories without being available for analytics. When this data is properly transformed and categorized, it can help drive additional insights, which could prove really valuable as you make decisions that move your business forward. AWS Glue is a fully managed extract, transform, and load or ETL service that automates much of the undifferentiated heavy lifting involved with data discovery and data prep. It automatically discovers and categorizes your data, making it readily available for search and querying. It auto-generates ETL code to clean, transform, and move your data from one data source to another, and provides tools to customize this code further to match your use case. And finally, it takes this code and runs it as ETL jobs on a serverless, fully managed environment with the necessary scheduling, dependency management, monitoring, and alerting capabilities. AWS Glue has three main components: a data catalog that is a central metadata repository for all your data, a job authoring component that auto-generates ETL code that is fully editable, and a job execution component that takes this code and runs it on a serverless Apache Spark environment. This is what the Glue data catalog looks like. It's a list of all your tables that map to various different data sources. Here you can see that you have data that sits in S3 with different formats, data that's coming from tables in Redshift, and data that is stored in a PostgreSQL database. The data is classified by applying various tags to it, and you can see various properties like the location of the database, location of the table, and the database that the tables reside in, etc., in one unified list. Glue Data Catalog is Hive Metastore compatible. It is integrated with Amazon Athena, Amazon EMR, and Amazon Redshift Spectrum out of box. You can use the Glue Data Catalog as a replacement for your external Hive Metastore for big data applications running on Amazon EMR. You can also query the data based on the table definitions that are in the Glue Data Catalog by using Athena or Redshift Spectrum. In addition to the Hive Metastore features, we have added a few extensions. We've added a search that allows you to search on key data attributes across your data sets, regardless of which service your data is stored in. You can connect by using connection information stored in the data catalog and use that information across various jobs as well as in crawlers. You can apply various different classifications to your data sets and categorize your data in the data catalog. And finally, you can keep a history of table versions in your data catalog and track how your data has evolved over time. There are multiple ways in which you can populate your data catalog. Since it is Hive Metastore compatible, you can run your Hive DDL statements and create your tables as well as register partitions in the data catalog. You can also use our bulk import script to import your metadata from an existing external Hive Metastore into the data catalog. And finally, you can use crawlers that help you automatically build your catalog as well as keep your catalog in sync with your data as your data changes. So let's take a look at crawlers and how they can help build your catalog. Crawlers go and scan the data that you authorize us to go and sample, and they extract schema information as well as some data statistics from this data set. In addition to the schema information for data stored on S3, crawlers also detect Hive-style partitions and register those automatically into the data catalog. Crawlers provide a host of built-in classifiers for popular data types that help identify data sets. In addition to the built-in classifiers, you can also write your own classifiers using grok expressions and write them in Python and apply them through a given classifier to the data that the crawlers can. Crawlers can run on a schedule or run on demand. And as they crawl the data on a recursive basis, they can also detect schema changes and apply different versions of the table into to the data catalog. And finally, crawlers run on a serverless platform that Glue provides. So there are no compute resources for you to provision or manage. So here's a list of classifiers that crawlers support. As you can see, crawlers natively support RDS databases, Amazon Redshift databases, as well as Amazon S3 databases. In addition to extracting the schema and adding table definitions to the catalog, crawlers also automatically detect partitions for data that is stored on S3. The way crawlers detect partitions is that they look at the similarity between schemas at the file level and then aggregate as they go up the hierarchy of various buckets. If the similarity is above a threshold, they assume that these files or directories map to the same table. Crawlers assign column names to partitions as they go up the bucket hierarchy if the buckets are named in the way Hive expects them, which is key equals value. If a name is not provided, crawlers are still able to detect partitions, but they would just assign a default partition name to the partitions, which then can be manually edited. You can also tell the crawlers to ignore certain file types or certain paths so that crawlers do not detect and process files such as marker files or metadata files that might be mixed with your data set. Here's an example of a table added by the crawlers. As you can see, the crawlers have populated certain table properties which show where the data is located and applied a JSON classification to the table based on the dataset data format. They've also collected certain data statistics like row count or average size of the row and added that to the table definition. And then finally, they've detected the table schema, including nested fields, and added that to the table definition as well. You can easily extend the table properties by adding your own custom properties that add a little more business context. And you can also edit the table properties as well as the table schema that has been detected by the crawlers. Crawlers also add new versions to the table definition if your underlying data has changed. So if you have new fields that have shown up in the subsequent partition or a new data drop, crawlers can easily pick that up and add those new fields as a new version to your table definition. You can also manually edit your table definition, which would create a new version, and then easily compare two different versions to find the delta. So far, we've seen how your data could be stored in various different data stores, and crawlers can help identify their schema as well as bring in the metadata for all of your data into a central repository and store it and show it in the Glue Data Catalog. We've also seen that Glue Data Catalog integrates with Athena, Redshift Spectrum, and EMR, which gives you the ability to quickly analyze your data and process your data as well as visualize it using various BI tools. So now let's take a look at how Glue ETL provides tools and functionality to take the data that is cataloged and then further prep it, process it, transform it to make it available for analytics. So the job authoring component of Glue provides three ways to author your job. It auto-generates Python code based on the source and the target that you provide. You can connect your own IDE or a SPARC notebook to Glue and interactively develop your ETL script. Or you can bring in code that you've developed elsewhere or found elsewhere, arbitrary PySpark code, and run it on Glue's serverless environment. Here is how Glue auto-generates your code. It first maps the schema of your source table to either your destination table or the destination store. And you can easily edit the mappings. You can reorder them, rename them, drop certain columns. Once you're happy with the mapping, you can ask Glue to generate the ETL code, which is basically Python code that's completely editable. The code Glue generates is human readable, so you can parse this code, you can take this code and run it on your local environment, and you can edit this code and customize this code. Glue uses a custom ETL library that we have built on top of SPARC for manipulating complex semi-structured data. This library also provides readers and writers to the data catalog, so you can easily read from the data catalog as well as write new data sets to the data catalog. And you can customize the script. You can either use our custom library, you can import your own custom libraries, or you can bring in arbitrary PySpark code and run your ETL jobs using your own code. And finally, Glue ETL code is meant to be shared via either GitHub or reused across different jobs. The code is completely parameterized, so you can pass in different sources and targets to the same script via multiple different jobs. So let's take a deeper look at what exactly is provided in Glue's custom ETL library. So Glue's custom ETL library is built upon a construct of dynamic frames. Dynamic frames are like Apache Spark's data frames, but slightly better. They are great at processing semi-structured data sets, in particular, cleansing these data sets, structuring them, restructuring them, and preparing them for analytics. Dynamic frames track schema at a record level rather than at the entire collection level. So there is no upfront schema required. This means that Glue can often pipeline transformations and process complex, messy data in a single pass. Data frames, on the other hand, require a schema either to be provided upfront or they do an extra pass over the data to compute this schema. The flexibility that dynamic frames provides also helps in capturing variations in data more precisely. You can easily track new fields, varying data types, and error records, and separate them either for post-processing or cache them inline. Glue provides a rich set of transformations. So let's take a look at some of them in detail. There is resolve choice, which allows you to decide what to do when you're seeing varying types in your data set. You can either throw away these types that you don't expect, you can cast them, or you can separate them into multiple columns. The second transformation that I would like to go over is apply mapping. Apply mapping allows you to flatten nested tree-like data sets. You can promote the fields that are within the tree up to the top level. You can also nest a flattened data set since it can go both ways. And finally, we have Relational Eyes, which takes apply mapping transformation to a whole new level. Relational Eyes basically recursively resolves choices, flattens and pivots arrays into auxiliary tables so that you can easily load this data into relational databases. Relational Eyes handles new columns, new data types very easily and automatically adds them to your target data set. It creates keys, foreign keys, and tracks them, as well as keeps track of error records, so you can easily separate those out into a separate bucket or a separate dynamic frame. And finally, you can run SQL on this decomposition, which is oftentimes magnitude faster than processing JSON data natively in relational databases. So here is a list of transformations that we support today in Glue's custom library, and we are working to add more to this list. Glue ETL library also provides spigots, which can be attached at any point in your ETL code to filter out partially processed rows or error records into a dedicated S3 bucket for you to easily debug your ETL jobs. You are certainly able to take advantage of all the cool transformations that we have in our custom ETL library, but your use case might just require something more, something that is not provided by Glue's custom ETL library, but is available in SPARC. So we do have ability for you to convert a dynamic frame into SPARC's data frame, run your complex SQL-based arbitrary PySpark scripts, and then convert that back to dynamic frames, either to write it to the data catalog or continue doing your semi-structured data processing. You can also import custom libraries as part of your ETL jobs and reference those in your ETL scripts. So all that is great, and you can certainly start with an auto-generated Glue script, edit it either offline or in our console. But if you really want to do interactive editing, you want to submit part of your code, get results very quickly, you need something like a notebook or an IDE to work on your script. So Glue provides a way for you to provision a development endpoint that gives you direct access to its serverless Spark environment and interactively develop your scripts using either a Zeppelin notebook or an IDE. And once you're ready with your script, you can upload that to S3 and create your ETL job and apply all the various orchestration logic to that job. So now I'll hand it to Ben, who is going to walk you through some of these concepts via a demo.
All right, thank you. So in this next demonstration, what we're going to show is how you could start investigating this dark data, how you could discover it, start to analyze it, visualize it, and then really create some custom ETLs using those developer endpoints. In order to do that, what we're going to start off by doing is creating a crawler. So as you heard, these crawlers are able to crawl a wide number of data sources. We're going to have it crawl at S3 location that we don't know very much about. Each crawler and each ETL process runs under an IAM role, and this role allows you to control access and really set up the least privileged access to various resources within your environment. Optionally, you could set up these custom classifiers using Grok that you heard about, in addition to the very, very large number of classifiers that are built into Glue to be able to identify data types. We're going to go ahead and step through this here next, and I'm going to select the S3 location that I don't really know much about. This is just I'm going to select at the bucket level and say, go ahead and crawl this entire bucket for me and derive any metadata from that location. It allows you to set up various ways of triggering that crawler. You can set it up based on a cron style expression. You could call through the APIs to crawl new data as it arrives through a S3 notification. Wide number of ways of triggering the crawler. We're going to run this on demand though. And then lastly, what we're going to do is we're going to create a new database to store this under. We're going to call it dark data. And really a database is a logical grouping of these tables. These tables might be relational databases tables, they might be data warehouse tables, it might be schema on read tables that are files within S3. And we'll talk a little bit more about that here shortly. So we're going to create a dark data database. And then the last section I want to highlight here are the schema changes. This allows you to really customize what should happen if the crawler, as it runs over time, discovers changes in the schema, or maybe all the data under a particular table gets deleted. How do you want to handle that? We're going to hit next and hit finish here. And then go ahead and we're going to run it. And what this is doing now is it's running that serverless crawler. I'm not provisioning any infrastructure myself, and it's crawling that resource. We happen to configure S3. You could very easily crawl your own RDSs, Redshifts, EC2 databases in your VPC behind a private subnet. So very, very powerful to be able to crawl various data sources. And then within a couple seconds here, if we go back to this table definition, this is the dark data database that we just created. And what you'll notice is it actually found 4 different tables, along with the various locations of where that data was found. Let's go ahead and start looking into this data now. We didn't know anything about this. These are data objects that are in S3. Right away, we could see the crawler's automatically identified this is a CSV. These are various JSON data sets. Let's take a look at the fact book. So what we can see when we look at this is a delimited file, and all the different attributes of the data. One of the things you'll notice here is even though this is a delimited file, which is all ASCII, the crawler's automatically identified various data types for us. We could very easily go in here and modify this ourselves if we'd like, but it does a really good job in terms of what the actual data is and identifying the data type of that data. Let's go ahead and start looking at this data a little bit more. What we could very easily do is we could select this factbooks table and then say, let's go ahead and view the data. And when we do this, it's automatically launching into Athena. Athena allows you to provide ad hoc queries against your data as it lives in S3. And the Athena data catalog is essentially using that Glue data catalog in order to know about the data set. So all within this live demonstration, what we've done is we've crawled the data source, we've identified various data formats, and now we're able to see the actual data that we're looking at here. So what we see here is we see various statistics about countries. So this fact data, what we see is country data, and it has to do with various statistics about each country. So what's the death rate? What's the birth rate? What's the export number? Using Athena, what we could very easily do now is we can start doing some SQL-based queries. Very, very powerful to start understanding your data because many folks know SQL, and we start immediately querying against this data set that we knew nothing about a few moments ago. And what we see is, various countries. What I just did in the query here is a simple formulation. What's the population compared to the area? I called that density, and give me the top 10 density countries in terms of population and area of that country. What we could do more is we could do a little bit more advanced analytics here. So in this next query, what we're going to do is we're going to take a look at energy generation. What's the density of the country, but also how much natural gas does that country produce? And how does that compare to the consumption of natural gas? And how much reserve does that country have in terms of natural gas? And we're going to pull the top countries back here in terms of how much natural gas those countries have in reserve and they're consuming. And what we see here are various countries based on this data set. And these are, the top countries in terms of how much natural gas those countries have. And what you could notice here are, the country names here, the density, and what that natural gas independence, essentially what that formula we defined up here is of how much it generates versus how much reserve it has and how much it's consuming. So that allows us to start drilling into this data set. Let's go back and look at some of this other data set. That one data set had to do with countries. We see another data set here that says countries as well. Let's take a look at that one. One of the things that we'll notice right away is this is JSON data by the classification here, JSON, and there's a nested object here. CSVs aren't really nested, but JSON could be very nested. So the crawler automatically identified this nested object, and we could go in here and look at what the fields are of that nested object. Just like before, if we want to start looking into this data using Athena, we could easily do that by selecting the table and selecting View Data again, and very easily jump into that data set. And what we could do here is start doing the same sort of thing. We could understand the data, start querying this nested object. So one of the things you'll notice here is this legislator data set has to do with how much legislation, how many people are in the legislation of that country, along with some additional metadata of the data. So the first data set we looked at was related to generation of energy, statistical information. This has to do more with the legislation in that country. Now that we've looked at these two data sets, we can start joining it. They both have to do with country, right? So what we could do, we know SQL, so we could just do a join here. Even though these two data sets are in different formats, the one data set we looked at was a CSV, the other was a JSON. We can still join the data sets very easily using these technologies. And when I hit run query here, you'll notice it returns very, very quickly. And we have information about the statistics of the country, but we also have the legislation in one result set that we can start analyzing and visualizing. Speaking of visualizations, SQL is very, very powerful, but what if certain users want to use this data that are more BI users or they don't necessarily know SQL? Well, that's okay. We could actually very easily integrate with QuickCite now. So I'm going to go ahead and launch into QuickCite. And what we could do here is we could create a new data set. We're going to select Manage Data, and then New Data Set. And by doing this, we can select a very wide number of different data sources. There's really rich features in terms of auto discovery when you're using AWS services, but you could also use other data sources within QuickCite as well, such as Salesforce, Teradata, Snowflake, various adapters to bring your data in. We're going to select the Athena connector here and create a new data set. And one of the things you'll notice is this dark data is showing up again here. This is the database that we just created moments ago. And these are the different tables that were discovered. I can select the fact book here and go into the edit phase. But what if we want to, this allows us to essentially prep the data and structure the data different ways, add fields, add calculated fields, do different sorts of functions on the data before visualizing it. What if we want to add another data source? Let's say we want to visualize both of those data sets together again. We could select both of those tables within Athena. And remember, I'm saying table here, but this data is still living in S3. It's using Athena to query the data. It's schema on read. So the data is staying in the raw form as CSV, as JSON within the S3 system. So what we could do is we could specify what the join criteria is here. And we're going to specify country. And by doing this, we could go ahead and hit apply. And what this allows us to do is now we created a data set that's joining those two Athena tables together, which we discovered automatically through the crawlers in Glue. And now we can hit save and visualize. Within that, what we're able to do now is see all the different attributes over here on the left-hand side. We can see country, code, and all of these other attributes that are in that joined data set. Very easily, I could select country here. And let's say I want to look at the area of the country and compare it to the population now and see more of a visual effect of that, rather than just a table that we showed earlier. We could do that, and maybe we want to see that as a tree map. Very, very easy. I select the attributes I want to see. I could manually change the visualization type if I want. QuickCite is very, very powerful at automatically determining various visualization types based on the data you select. But here, what we're able to see is that in a very quick chart, the size of the box is the area of that country, and the coloring is how populated it is. So the smaller boxes that are darker or more densely populated, the larger boxes that are lighter or less populated in terms of density. So very, very easy to go end to end of not knowing anything about that data, being able to start querying it using SQL and start building visualizations on it. Now that we've done that, though, what if we want to really curate this data set? We had some of the nested objects within there that we really haven't started analyzing. What if we want to load that into a data warehouse and really empower our business users to really start doing very, very advanced analytics through various BI tools like QuickCite? That's where we're going to dive into the developer endpoints. So the developer endpoints could be launched over here on the navigation pane of the Glue console. And I've already launched a developer endpoint. It takes a couple of minutes to launch, so I've already launched that. But as soon as you launch that and you either attach, have it launch a notebook for you or attach your IDE to it, you can start developing your own ETLs very interactively. I'm going to be using a Zeppelin notebook here to demonstrate the capability. So I already have a notebook defined within here. And what this little fragment does here is it's using Glue libraries to be able to very easily read from that data catalog. So it's reading the countries and factbook data, the same data set that we've been querying within Athena, the same data set that we've been visualizing within QuickCite. But now what we're going to do is we're going to start looking into this data and start transforming it and understanding it even more. The first thing that we could do, just to show the interactive nature, is let's just pull some very simple statistics and print the schema of these data sets. So one of the things that you'll see is both data sets have a few hundred rows, and then you can actually see the schema defined for each of these data sets. So this is the factbook schema here with all the statistics of the country. And then the country's legislation data set, you can see is that very nested JSON. So there's the root elements here. You can see legislators, you can see person count, and then under each person count, you can see an array of legislation periods. So this is a very nested JSON object that we want to start looking at getting into our structured form to really optimize the queries for. Before we do that, though, what we could do is, let's say we only care about certain attributes out of the fact book. What we could do is, we could use some of the dynamic frame APIs. We could use the select fields call here, and we could just say, I want to select these fields out. One of the questions you might have is, how do I know what functions I might be able to call on the dynamic frame? There's a nice API that you could go to on the website that has various fields. So this is the select field call that I'm doing now. It describes what the parameters are. Really nice feature. You could also define thresholds. If there's any errored rows, how do you want to handle that? In terms of the entire process, what's the total threshold of errors until the job should error out? So a lot of additional advanced features in each of these transformations on that dynamic frame. So let's go back to coding. We're going to switch over back to this notebook here. And let's look at this data set a little bit more. Within this interactive notebook, we can start converting to a dynamic frame and pull some of the statistical information from that. And when we do that, what we can see is these are the various attributes we selected in the line of code above. And we can see what the count is of each of these fields. So for example, country, there's a record for every, there's a value for every record. But things like natural gas reserves, only a small number of the countries have a natural gas reserve. So you can start pulling some of the statistical information out here. You could also drive things like machine learning models from this. Speaking of that, let's do a simple correlation here. So what we're going to do is we're going to do a quick correlation call saying, what's the correlation between how much a country generates in terms of natural gas and how much it consumes? And what we see is a very high correlation. So countries that are producing a lot of natural gas has the natural tendency of consuming that gas. What if we want to look at oil instead? Another form of energy. What we could very easily do in this interactive notebook is we could say, okay, let's look at the correlation of that. And what we see is a much lower correlation. So, many countries are consuming oil that aren't necessarily producing it. So oil is exported much, much more than natural gas is. So that allows us to start really looking at the data, start doing some of these queries. Let's join these data sets together. In order to do that, very easily, I could call a join call within the Glue libraries, joining the two dynamic frames together. In addition to that, when I run this, you're going to notice a couple other lines of code here. I could also convert to a data frame and do select statements. And what I've done here in this 4 lines of code or a few lines of code is I've joined the data sets together, and then I've selected only the countries that are generating natural gas reserves. And what you'll notice is this filtered number, this joined data set number, the 69, is the same exact result set size that we queried through Athena. So when we were doing this query through Athena, doing the select statement, we're able to interact with the same data catalog, do the same source selects through the essentially through the jobs if we'd like to, through the dynamic frames in a data frame. So what if we want to take this complex object? So this joined object here is complex, right? It has an array of structs. It has another array of structs. What if we want to start populating our data warehouse with that data? What we're going to do now is we're going to call another function. We're going to call that Relational Eyes call. And what this will do is it will actually create a set of tables for us, a set of dynamic frames. And as soon as we do that, we can see 3 dynamic frames created for us. One represents the root level. Let's go ahead and take a look at that now. In order to do that, we could very easily select the dynamic frame out of the collection and say, just show me the records. And that's what this is going to do. And you see the the first 20 records. And one of the things you'll notice is this ID, this ID number here, 1, 2, 3, 4, 5, 6, 7. This is the ID that's used in various other child tables. So if we go ahead and do another query here, but instead look at the child table of country legislators, you're going to notice something. One is you're going to notice an index, but the other thing you're going to notice is an ID. And one of those represents that primary foreign key relationship, and the other is actually the other ID, the count, because it's a one-to-many. So let's take a look at this data set here by just doing a simple show. And what we can see here is, here's the 2 IDs. So the first column here is the ID in that base table, that countries table that we looked at a moment ago. And then this index ID is the record, how many there are in that particular entry. So for the first entry in countries, there's 2 of these legislators, and we could see the lower house, upper house of those legislators. So what we step through here is essentially we first discovered the data using the crawlers. We're able to start querying the data set using Athena. We're able to visualize it using QuickCite, but then we're able to use things like that serverless ETL in order to very easily understand, transform, get this data in a really structured format to be able to populate a data warehouse. And we did all this without spinning up a single server, having to worry about managing that server, all using various aspects of those 3 services.
All right, thanks, Ben. That was a great demonstration. It really ties all the different parts of Glue together and shows integration with other services like Amazon Athena. So just in conclusion, Glue Data Catalog, job authoring, and job execution form the 3 main components of Glue. Together, they can help you discover and categorize your dark data, process it, and transform it so that it's readily available for various analytic needs. And that's it. That's all we have for you today. We'll take your questions now, and the developer resources link here provides links to our GitHub repository, which has some samples as well as the Glue custom library and some additional resources like videos, etc. So thanks all. Thanks for attending.